Assalamu alaikum wa rahmatullahi wa barakatuh. Uh, Today I'm going to show you a small optics problem. The problem is like this. There is an object which is at infinity, and the rays of the object fall on a spherical glass object. Okay, and then the image is formed at certain point. We have to find the distance of the image. Okay, from one particular position. So this is the question. A parallel incident beam falls on a solid glass sphere prove that the for paraxial rays, the distance of image from the outer edge in terms of refractive index mu and the radius r of the sphere is this. So we have to find the location of the final image. So here is a rough diagram I have drawn. Okay. So the rays of light come from infinity. They are incident on the first surface. Had the second surface not been present, then it would have formed the image at the point I1. But due to the presence of the second surface, the rays of light further go inside the sphere and gets refracted, and finally the image is formed at the point I. The the image I1, which was formed due to refraction from the first surface, acts as the virtual object virtual object for the second surface, and the final image is formed at this point I. Okay, so the formula that we should use is the refraction at a curved surface formula, which is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. इसको मैं briefly आपको बता देता हूँ. Mu2 is the refractive index of that medium where we have the image. Mu1 is the refractive index of that medium where we have the object, and mu2 minus mu1 by r. R is the radius curvature of the curved surface where the refraction happens. So there will be two cases in this question. The first case being when the ray of light coming from a very distant source is incident on the first surface. So that will be case one, and for that we take the image formed at the point I1, which is at a distance V1 from the first surface, and the radius of curvature is taken to be r. The image, sorry, the object is taken to be at infinity. So we have to use proper sign conventions for our correct answer. So mu1 is the refractive index of that medium where there is the object, and the object is at infinity, as you can see here. So we are saying air in all the cases. That means this particular spherical surface is surrounded by air on both the sides. So mu1 is equal to 1. Had this second surface not been there, then the image would have been formed at the region of the first of the spherical surface, which is having a refractive index mu. So mu2 is called it is taken to be mu, and the radius of curvature of this surface is plus r, because it is along the direction of the incident ray. Now use the reflection at a curved surface formula, and you mu2 by v minus mu1 by u is equal to mu2 minus mu1 upon r. So mu2 is mu here. Put all the parameters in this equation, and what you get is mu v1 is equal to mu times of r by mu minus 1. You can do it on your own or listen to the explanation, and if you have any doubt, the solution is present before you. And then this v1 value we have found out. That means the distance of this particular image I1 from the first surface comes out to be mu times of r by mu minus 1. Now this ray of light further travels inside the lens, inside the glass sphere, and is further refracted, and the final image is formed at the point I. So this particular I1 acts as the virtual object, as the virtual object, as the virtual object for this image I1. For this image I. So it appears as if the rays of light are coming from I1. So what is the distance of I1 from this particular point? It is the entire distance is V1. This entire thing is 2 times of R. So the object distance is equal to V1 minus 2 times of R, which is positive. So now come to the case 2, where the reflection is happening at the second surface. So in this case, by the way, this object, virtual object, is in this medium. Please mind it. Virtual object is in this medium, which is having a refractive index mu. So the sign convention is positive. The image is formed in a region of refractive index 1. So mu 2 is equal to 1, and the radius of curvature is negative. Okay, because of the sign convention. So this is the thing which you get. So u is equal to v1 minus 2r, which I showed you just now. You see v1, the value of v1 is here itself. Put the value of v1 here, and you solve it and you get this. Now again use the spherical, and again use the formula, which, okay, reflection rate curve surface formula. You use this formula, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. So the image is formed in air, and the distance of the image from the pole is v2. This is the thing which you see, and object is in mu, and this is the value of the object, and distance v r 2 minus mu by mu minus 1, 1 minus mu upon minus r. Solve it, and finally what you get is v2, that is the distance of the final image from the pole, which is 2 times into 2 minus mu by 2 times of mu minus 1. So this is the short explanation to the answer of the problem. So assalamu alaikum wa rahmatullahi wa barakatuh.